morning everyone. How are you all? In today's class, we are going to learn about polarization and its types. So we are going to learn about polarization of a light. So we can start with what is a light. So what is light? Light is an electromagnetic wave. Light is an electromagnetic wave. According to James Maxwell, light consists of oscillating electric and magnetic fields that are perpendicular to each other and also perpendicular to the direction of propagation. In ordinary light sources like sunlight and bulb light, the electric field vibrations occur in all the possible directions perpendicular to the direction of travel. This type of light is called unpolarized light. And in unpolarized light travels in every possible direction. However, when the vibration of an electric field are restricted to the only in a single direction or a definite pattern, the light is said to be polarized. Okay, let's understand polarization through some examples. Okay, this can be understood with the example of sunglasses. Imagine you are walking on a road. You are walking on a sunny day. Light falls from sunlight. Light falls from sun to light from the sun falls on the road, water surface, and car windshield. When the light reflects from these flat surfaces, something important happens. What happens to the reflected light? Sunlight is originally unpolarized because vibrations in all directions perpendicular to the motion. But when it reflects from a horizontal surface like water or a road, the reflected light becomes partially polarized. Most of the vibrations becomes horizontal. This horizontal polarized light causes this strong glare and it causes eye strain and reduces visibility. And this phenomenon was first studied by Italian Louis Malus. Okay, let us try to understand with the two cases. First, with the normal glasses like mine. What it does is it only reduces the amount of light it can pass, and it does not block specific vibrations of the light, and it allows both horizontal and vertically polarized light to pass. As a result, I can still see air from the road and from the water. In a second case, like if I am using a polarized sunglasses, what happens? Polarized sunglasses contain a special filter. This filter, what it does is it blocks the horizontal vibrations, and it only allows vertically vibrations to pass. So since glare is mostly horizontal, this horizontally polarized, and it gets blocked in polarized sunglasses. As a result, I can have a clear vision, I can have a reduced eye strain with a better contrast, and it is safer while driving. So, if the electric field oscillations are horizontal, the rays are blocked. If the electric field oscillations are vertical, the rays are allowed. So, polarized sunglasses act like a gate that allows waves in only one direction, and normal glasses reduce this intensity, but polarized sunglasses reduce glare by blocking horizontally polarized reflected light. Now we understood what is polarization and what is unpolarized light. Now let us learn about these different types of polarization. There are three types of polarization: linear polarization, circular polarization, and elliptical polarization. In linear polarization, it is like in a plane polarized light, the electric field vibrates in only one fixed direction, perpendicular to the direction of propagation, and the fields oscillate in single direction. We can represent it in x axis like this. Polarization. In plane polarized light, the electric field vibrates in only one fixed direction, perpendicular to the direction of propagation. How it happens is, both the horizontal and vertical components of the wave are in phase. For example, radio signals transmitted from a vertical antenna, which is vertically polarized, or a light reflected off a horizontally surface like a rope, creating a layer which is horizontally polarized. The first and simplest type is linear polarization, also called plane polarization. In this case, the electric field oscillates in only one fixed direction. Imagine a rope tied to a ball. If you shake the rope only up and down, the wave travels forward, but its vibration is confined to a single plane. Similarly, in linearly polarized light, the electric field vibrates in a single straight line. If the electric field oscillates vertically, we can call it vertically polarized. If horizontally polarized. Like mathematically, if light is traveling along this z-axis and the electric field oscillates along this x-axis, then the light is linearly polarized. This is the simplest form, and it's processed using a device called polarizers. Now let's talk about the circular polarization. This occurs when two perpendicular electric field components of equal amplitude combined with a phase difference of 90 degrees, that is pi by 2 radians. In this situation, the tip of this electric field vector does not move in a straight line, but traces a circle as the wave propagates. Imagine looking at a wave from the front. The electric field rotates uniformly with the time. Depending on the direction of rotation, it may be right circularly polarized or left circularly polarized. This type of polarization is important in optical communication and quantum optics because circular polarization carries angular momentum. Now let's talk about elliptical polarization. This is the most general form of polarization. If the two perpendicular components of the electric field have unequal amplitudes, then or a phase difference other than 90 degrees, the tip of this electric field faces an ellipse. Thus, elliptical polarization is a generalized case, and both linear and circular polarization are special cases of elliptical polarization. If the elliptical, if the ellipse collapses into a straight line, it becomes linear polarization. If the ellipse becomes a perfect cycle, it becomes circular polarization. So, in our class, we learn about polarization and the different types of polarization. Those are linear polarization, circular polarization, and electrical polarization. If you have doubts, you can ask me. Thank you.